Greetings, everyone. I believe you are well. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. I believe you are all well. Right. Today, guys, I want to take you through trigonometry for grade 12. Particularly, this will be part 1. Then I also have part 2 and part 3. Right. In terms of trigonometry for grade 12, one must be able to familiarize himself or herself with the following concept in order to enjoy trigonometry. Right, let me elaborate them. Then from there, we'll go straight to the equations. Number one, we know in most of the cases, most of the exam papers, the format of the paper usually looks like this, particularly for grade, like for trigonometry. Right, the format of the paper looks like this. Usually in trigonometry, they usually ask 3 questions, particularly for trigonometry. You find that, let's say, if it's question 3 and question 4 and also question 5. It's just an example. In question 3, you find that they're just asking all the grade 11 concepts. And also the grade 12, particularly on the double angles, double and compound angles. Then again, question 4, they usually ask, yes, trigonometric graphs, the trig graphs only. And the last question, it is based on height and distance problem. Where they actually like height and distance problem, which includes the use of sine rule, cosine rule, and also area rule. Not forgetting SOHCAHTOA, trigonometric ratios. You have a right angle triangle. So usually trigonometry usually comes in 3 questions. I'm not quite sure whether, but in terms of the questions, its format is like this. So it usually comes in 3 questions. The first question for trigonometry is just based on grade level concept, which is what I want to address now, which I will call it part 1. So which means in the next video, we'll talk about the trigonometric graphs. And the last one will be the height and distance problem. Right. Without wasting time, let's just deep dive into the part 1. And I'll also explain what is it that a learner is expected to know in order to answer questions that are in part 1. Number 1, a learner must be able to know grade 11 concept. Number 1, you should be able to know the trigonometric ratios, to know and use them, trig ratios, which you call them the SOHCAHTOA. And remember, these trig ratios are applied in a right angled triangle. So if we have a right angled triangle, then we can apply SOHCAHTOA. We know sine is opposite over hypotenuse, adjacent is cos over hypotenuse, tan is opposite over adjacent. And you must also familiarize yourself with the other symbols or the other letters that we can use except this. For example, if we say we have the sine of theta, we know sine in terms of SOHCAHTOA, it's opposite over hypotenuse. or can be used interchangeably with, if it's opposite, you can also use y. Hypotenuse, you can use r. So you must know that opposite is the same as y. Hypotenuse is the same as r. For example, if you have cos of an angle, cos is adjacent over hypotenuse, which is the same as x over r. Then the tan of an angle is opposite over adjacent. The opposite is the same as y, and the adjacent is the same as x. So you must know that you use this interchangeably. Secondly, one must be able to understand the trig identities, particularly for grade 11. The first one is the quotient one, where we say the tan of any angle, it's sine over cos. And another one, 1 over tan, is the same as cos over sine. And sine squared, this is a squared identity, sine squared of an angle plus cos squared of an angle is equals to 1. And within these squared identities, we can manipulate this expression. It depends with what we are looking for. So let's say we want to we can make sine squared the subject of the formula. So it's still the same as saying, if we want sine squared of an angle, this is the same as 1 minus cos squared of an angle. Or also, if you want cos squared of an angle, this is the same as 1 minus sine squared of an angle. So it's very important for one to be able to know these trigonometric identities. Then the third one, under trigonometry for grade 11, particularly which is assessed in part 1, is the issue of reduction formulae. And this is one, this is very important. You need to know the reduction formulae by heart. But in a Cartesian plane, if this is the y-axis and this is the x-axis, we know we're going to have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And starting from the x point, the zero reference point, if we increase this angle by 90, it means we're going to have 90 degrees, 180, 270, 360. We can keep on increasing. If we increase, this will be 450. Sorry, 540, 630, and so forth. So which means in the first quadrant, because in mathematics, when we want angle to be positive, we have to move clockwise, the anti-clockwise direction. So it means this is our first quadrant where we have 90 minus an angle. 90 below an angle, and this is 90 above an angle, which is 90 plus. Then 180 here. So this is 180 below an angle, so it's 180 minus an angle. And here it's 180 above an angle, so it's 180 plus. So 270, 270 below, this will be 270 minus an angle, and 270 plus an angle, together with 360 minus an angle. And the negative angle is also in the fourth quadrant. So in the first quadrant, we can also have 360 plus an angle. So it's very important to know this reduction formulae. It's very, very, very important to know this. And this reduction formula usually goes with the special angles. Special angle of 30 degrees, special angle of 45, and special angle of 60. Usually we use these special angles when we are asked to evaluate something or simplify without using a calculator. So it's very important for one to be able to know these things. Number one, I said, is the trig identity, trig ratios. soccer tour. Number 2 is the trigonometric identities for grade 11. Sine squared of an angle plus cos squared of an angle is equals to 1. 1 over tan, it's cos over sine, and tan alpha is sine over cos. Then another important part that you need to know when you are solving trigonometric identities is the issue of using cofunctions. Which are trigonometric functions that are actually changing when we are using 90 degrees angle, when we are using 270 degrees angle, and so forth, 450 degrees angle, and 680 degrees angle, and so forth. How do, like, in terms of the angles that goes with 90 and angles that goes with 270 in the Cartesian plane. For example, remember here the angle was 360. If we increase this angle by 9, this will be 450. By 90, this will be 540. By 90, this will be 680. So which means any angle that goes with 270 or goes with 90, it's also part of the cofunction. Which are trigonometric ratios that are changing whenever you're using 90 or 270. Which means the cofunction of sine becomes cos. And the cofunction of cos becomes sine. So it's very important for you to know the cofunctions when we are solving problems. Then another key aspect when we are solving trigonometric ratios and some stuffs is the issue of being able to solve trig equations, where you need to familiarize yourself with the general solutions. The general solutions of sine, the general solution of cos, and the general solution of tan. We shall not talk about them here because there is a video that I've created for the general solutions. Kindly visit the video, the YouTube video on general solution. Then you will learn a lot from there. Then another key aspect that you need to know, because since you're in grade 12 now, you need to familiarize yourself with the compound angles. Compound angles and double angles. Compound and double angles. Remember, we have a compound angle for sine and we have a compound angle for cos. And this one I actually provided for you. So it's very important for you to know these things in order to solve trigonometry, especially for the first question. As I said, usually trigonometry comes in 3 questions. The first question addressed whatever I'm talking about. Then the second one is the issue of graphs. It's now focusing on graphs. And the third one is the height and distance problem, where it uses sine rule, cosine rule, area rule, and also a bit of soccer tour. Right. Let's now deep dive in the questions. I think now you'll be able to follow with me. So the trig ratios, trig identities, reduction formulae, special angles, cofunctions, general solutions, and the compound angles and double angles. Okay, all right, let us now solve the questions. Okay, the first one, it says if tan of an angle, if tan theta is equals to 12 over 5, if tan theta equals to 12 over 5, where theta is an angle between 0 and 90, show that 13 sine theta plus x is equals to 5 sine x plus 12 cos x. So first of all, we need to look on what we are given already. We are told that tan theta is equals to 12 over 15. And we need to show that stating sine theta equals to 5 sine theta, I'm saying sine x. I apologize. 13 sine theta plus x equals to 5 sine x plus 12 cos x. Ladies and gentlemen, these are equations where usually they will say, evaluate this with the aid of a diagram and without using a calculator. In most of the cases where they want you to evaluate these trig ratios when you are given boundaries or intervals, usually you need to have a sketch. There must be a diagram or a sketch. I'm not saying that all the time when you're given this interval like this, you have to draw a sketch, but I'm saying questions where you need to evaluate something, then with these kind of conditions, then in most of the cases, you need to draw your right angle triangle. I believe, guys, you're following. Okay. Okay, just a minute, guys. I want to sort something. Right, then now, okay. Okay, let me first erase here. Okay, then let's now do the solving. So we are told that tan theta equals to 12/5. First of all, before we do this, because in most of the cases they will say without using it, means we do not have to calculate the angle first. So what we do is we first look on in this trigonometry ratio. Okay, fine. We know according to SOHCAHTOA, what is tan in terms of SOHCAHTOA? In terms of SOHCAHTOA, tan its opposite over adjacent. And we know opposite is the same as y, adjacent is the same as x. Now, first of all, let's check the sign of our ratio. This value at 12/5, it's actually a positive value. And since we are given this boundary, it means we need to look, or we need to identify a quadrant where tan is positive. Remember, I believe you are able to use a reduction formula. All students takes coffee or chocolate. We know that in terms of the quadrant, this is the 0 point, this is the 90, this is 180, this is 270, back to 306. We can keep on increasing. Now, we know that we first look at the ratio. The ratio is 12/5. This is a positive number. So since this is the positive number, it's telling us where tan is positive. Where's tan is positive? Tan is positive in the first quadrant and in the third quadrant. But according to this boundary, we are told that the angle theta should be an angle between 0 and 90. So which means that the right angle triangle that we're going to construct, because we are given a condition to say it should be between 0 and 90, it means it should be in the first quadrant. Because in the first quadrant, that's where the angle is between 0 and 90. So our angle is in the first quadrant. The tan of theta, which is 12/5, it is in the first quadrant. Because we are given a condition. So which means that how do we represent this angle theta? Always we construct the angle from the x-axis up until it touches the hypotenuse. So this is our theta. So it means if we're constructing in the fourth quadrant, how will we represent the angle? Always from the positive x-axis up until it touches the hypotenuse. So this will be our angle. But because of the condition, we're not gonna draw it in the third quadrant, because the condition says the theta should be between 0 and 90. So it means our right angle triangle should be in the first quadrant. because of this condition. And beside our answer is positive. So now we're going to say, since tan theta is 12 over 5, what is the y value there? The y value is 12. And what is the x value? The x value is 5. So it means you're going to use theorem of Pythagoras to determine the value of r. Remember, r is always positive, hypotenuse. So what is the x? The x is 5 squared. The y is 12 squared equals to r squared. This gives us 25 plus 144 equals to r squared. So the r squared will be 169. Then always r is positive, so we're going to put the root sign without making plus and minus. So the r will be 13. So we know the value of r here, it's 13. So what we're going to do, then we're going to say in our right angle triangle in quadrant 1, the r is root 13. What is the opposite? The opposite is the y. What is the y? 12. And what is our x? Our x here is 5. So now we constructed our right angle triangle. Remember, there's a mark for doing this. Now, from there, we can now answer the question. It says we need to show that 13 sine theta plus x equals to 5 sine x plus 12. And how are we going to do that? Let's now solve the question. Now, let's look on the side that is actually, isn't it we want to prove that the left and the right are equal. So we can start with the left-hand side. It's okay, fine. On the left-hand side, we have 13 sine theta plus x. Look, theta plus x. We took two angles added together and applied in a trigonometric ratio. It means this is a compound angles. This now becoming a compound angle for sine. So we know compound angle for sine, it's sine, cos, sine. Unlike cos, which is cos, sine, sine. So it means you're going to say 13 into, we expand this. This is sine theta, according to the compound angle, cos x plus cos theta sine x. I believe you are following. Then within that, we have to substitute by, we're going to say 13 into, remember here we're using theta. This is the theta, it's not the x. So what is the sine of theta? What is sine in terms of Sogatua? Opposite, which is 12, over hypotenuse is root. I'm going to say it's 13. I apologize, guys. Not root 13. So this is 13. So it's going to be 13 multiplied by cos x plus, what is cos theta? Cos is adjacent over hypotenuse. Adjacent is 5 over hypotenuse is 13 multiplied by sine x. Then we will multiply everything by 13. If we multiply everything by 13, 13 multiplied by 12 over 13, this gives us 12 cos x. And 13 multiplied by 5 over 13 gives us 5 sine x. So now we have proved, because this is the same as 5 sine x plus 12 cos x. So we have answered the question. So in most of the cases, ladies and gentlemen, when we are given this, you need to, when we are given a trig ratios with conditions like this, you must know we have to construct a right angle triangle. I believe you're following. Now let's move on to the next question. It says, if sine 2 beta is equals to 3 over 5, where the 2 beta, not the beta, where the 2 beta is between 90 and 360. Determine the value of sine beta without using a calculator. This is one of the guidelines. So, okay, fine. If they say without using the calculator, just say without having to solve for the angle first. I believe you are following. So now we're going to do this. Okay, let me just get a blank space here. We have to say, okay, fine, let me raise here. We are given sine 2 beta is 3/5. Sine 2 beta is 3/5, and we are also given the condition, the boundary, that 2 beta should be between 90 and 360. So which means once you are given that type of expression, it means you need to construct a right angle triangle. So let us now solve the equation. Okay, I'm going to write down. It says sine 2 beta is equals to 3/5, 3/5. But we are told that this 2 beta is between 90 and 360. This is a condition, which means we need to consider this. First of all, when we are given this, first of all, we look at this ratio. This ratio on its own is positive. So it's telling us why sine is positive. So if we construct our right angle triangle, let me say our Cartesian plane, sine is positive in which quadrant? Sine is positive in the first quadrant and also in the second quadrant. So it's either we construct in the first quadrant or in the second quadrant, but we are controlled by the condition. So sine is positive in the first and second. And what is sine in terms of SOHCAHTOA? Sine is opposite over hypotenuse, which is the same as y over r. So already we know the value of y, it's 3. We know the value of r is 5. So it means you have to determine the value of x. But here they're saying you need to consider where sine is positive, but it should be between 90 and 360. Now, where is this 90 and 360? 90 is here. So it means you need to consider moving from 90 up until 360 degrees, somewhere here. So it means we need to choose where sine is positive, but from 90 up until 360. So obviously, we have to construct a right angle triangle in the second quadrant. So it means our right angle triangle here, it will be in the second quadrant because of that condition, not in the first quadrant, because the boundary already, it's above 90. So it means how are we going to draw our angle from the x-axis up until it touches the hypotenuse. But now we're not going to put theta. The angle here is 2 beta. So it means our angle here is 2 beta. We're dealing with 2 beta, not beta. We're dealing with 2 beta because the condition is for 2 beta. Already we know the value of y. The value of y is 3. And the value of r, which is the hypotenuse, is 5. So it means you have to know the value of x. And this value of x, since it's in the second quadrant, the x will be negative. So you're going to use theorem of Pythagoras to solve for that x. But we have to take a negative one, I mean to say. So you're going to have x squared plus y squared is equals to r squared. We do not know the x. What we know is the y is 3 and the r is 5. So this becomes 9, 25. Then we transpose 9 to the right hand side. 25 minus 9 is 16. Then we apply the root sign, but you have to allow plus and minus because we need to choose this plus minus 4. So which one is the correct answer? X is negative 4 because it is in the second quadrant. Okay, now I believe you are following. So what does the question say? It says determine the value of sine beta without using a calculator. We want sine beta. And be careful, we want sine beta, not sine 2 beta. The reduction, this Cartesian plane uses 2 beta, and here we want sine beta. And now, how are we going to solve this? We're going to say, okay, fine. Because now we are given 2 beta and we're looking for sine beta. And 2 beta, remember, it's part of the double angle. So let's go and look for a double angle which will have sine beta in it. Obviously, we cannot use double angle for sine because sine has both cos and sine. I'm saying, yes, sine has both cos and sine. So it means we are going to consider this. We're going to say, okay, since we want sine beta, let's write the double angle for cos. The one with sine only. Sine 2 beta is the same as 1 minus 2 sine squared beta. So I've used the double angle for cos. But this one, I can get it, this one, because this reduction, this Cartesian plane uses 2 beta. And what is cos in terms of 2 beta? Cos is adjacent, which is minus 4 over 5. We know this because this is talking about 2 beta. 1 minus 2 sine squared beta. Now I have to determine sine beta. To do that, I can either transpose 1 to the left-hand side or transpose 2 sine squared beta to the left-hand side, then minus 4 over 5 to the right. So this will be 2 sine squared beta equals to 1 plus 4 over 5. So we're going to have sine squared beta. It's 1 plus 4 over 5 is just 9 over 5. Oh, there's already 2 there. So we're going to divide there by 2 and we divide there by 2. So what would be the answer? The answer would be sine squared beta. The sine squared beta will be 9 over 10. And here we put the root sign on both sides to get sine beta. But now we're not gonna do plus and minus. Why? Because sine is positive in the second quadrant. So it means we have to consider the positive value. So we're gonna have sine squared beta. Root 10 or root 9 over 10, this is the same as 3 over the root of 10. 3 over the root of 10, or 3 root 10 divided by 10. 3 root 10 divided by 10 is the same as, because usually calculator rationalizes the denominator. I believe, guys, you are following. I believe you are following. So it's very important to read the question and understand it. Okay? Then let's move on to the next question. Okay? One point three. 1.3. So we are done with 1.1. Then 1.2. Now we move on to 1.3. 1.3, it says, prove the following identities. We want to prove that 2 sine squared x divided by 2 tan x minus sine 2x equals to 1 over 10. Usually we know when we are proving, what do? We start with the complicated side. Obviously, it will be the left-hand side. So we're going to say 2 sine squared x divided by 2 tan x minus sine 2x. Obviously, the numerator will not change. It will just be 2 sine squared x divided by. Denominator, we have 2 into. We know tan is what? It's sine over cos. Minus sine 2x. This is a double angle. Which is the same as 2 sine x cos x from the formula sheet. And since this expression here, it's a fraction, it means you have to divide it by 1 to make this a fraction 2. So that we simplify fractions. So this is the same as 2 sine squared x divided by, let me just write like this, the 8 over 1, 2 sine x, this becomes 2 sine x over cos x minus 2 sine x cos x over 1. Let's now simplify fractions. This will be 2 sine squared x divided by, I believe you know how to simplify fraction. And how do you simplify fraction? You multiply the denominators together, cos x times 1 is cos x. Then you cross multiply here. 2 sine x multiplied by 1, this becomes 2 sine x minus 2 sine x cos x multiplied by cos x, this becomes 2 sine x. Cos x times cos x, this becomes cos squared x. Then you close the brackets. If we simplify this is the same as 2 sine squared x divided by, I've changed this division to this format, divide by this expression. And what is the common factor in the numerator? Is 2 sine x. If I pull 2 sine x, I'm going to remain with 1 minus, same applies here, cos squared x divided by cos x. Now, what we're going to do is we have to change the division into multiplication. We have to change division into multiplication, ladies and gentlemen. And to do that, it means this will be, remember, now we have so this is over 1 because like it is a fraction already. So we're gonna change this into to have this 2 sine squared x divided by 1. Then we change division to multiplication. It means you have to transpose the other part, this part, to make the reciprocal. So it means this will be cos x over 2 sine x into 1 minus cos squared x. So, and since we have multiplication here, we are allowed to divide terms that are the same. So now what we're going to do, or another way would be, let's multiply the numerators together. This will be 2 sine squared x multiplied by cos x divided by 2 sine x into 1 minus cos squared x. So the 2 and the 2 will divide. Sine x and sine x will divide. So we're going to remain with sine x at the numerator together with cos x. And at the denominator, what is, remember we know sine squared x plus cos squared x equals to 1. So let's make sine squared x the substitute of the formula. So sine squared x is 1 minus cos squared x. So it means where there is 1 minus cos x, cos squared x, we're going to put sine squared x. So this becomes sine squared x. So it means sine x here will divide with the sine x here. So we're going to remain with sine x here. And this will give us cos x over sine x. And what is cos over sine? This is the same as 1 over tan. So we've proved the identity. We proved the identity. I believe you're following. I believe you're following. Okay? So the left-hand side and the right-hand side are equal. Okay? Then we move on to the next question. Just a minute, guys. Okay, right. Then now let's go up. That was 1.3, if I'm not mistaken. Then the second one says, determine the general solutions. Determine the general solutions for which this identity is undefined. And I think I've said this last to say, for undefined, for the expression to be undefined, the denominator should always be 0. For undefined, denominator should always be equals to 0, because any number divided by 0 is undefined. And what is our denominator there? Our denominator is 2 tan x minus sine 2x equals to 0. Or another denominator is tan x equals to 0. So this will become 2 tan its sine over cos. Then we can now transpose this side. So this will be sine 2x. And we know that, okay, this will become 2 sine x over cos x. What is sine 2x? Sine 2x is a double angle, is 2 sine x cos x over 1. Let us cross multiply. So this will give us 2 sine x equals to 2 sine x cos squared x. Then we transpose this to the left-hand side. So it's 2 sine x minus 2 sine x. 2 sine x cos squared x equals this. Remember, we still have tan x this side. So what is the common factor? The common factor is 2 sine x. So we're going to remain with 1 minus cos squared x equals 0. But still there is tan x there. So which means 2 sine x equals to 0, or 1 minus cos squared x equals to 0. Or even tan x equals to 0. If we divide this one by 2, this will give us sine x equals to 0. Then if we transpose this, let's say we transpose cos squared x to the right-hand side, we're going to remain with 1 equals to cos squared x. Then we apply the square root, but this time around we have to allow plus and minus. So it means we're going to have cos squared x is plus minus 1. Or tan x equals to 0. And we know when we determine the general solution for sine, how many answers are we supposed to get? 2. So we're going to say second function sine of 0. It will give us 0 plus k times 360 when k is an element of integers. Then the second one will be 180 minus the first one, which is 180, plus k times 360 when k is an element of integers. Same applies with the cos. In terms of the cos, we must also get 2 answers. So here we're going to say cos x equals to 1, or cos x equals to minus 1, because we allowed plus and minus. So let's now, remember when you're dealing with cos must have 2 solutions with plus and minus. So second function cos 0. Second function cos of 0, this will give us 90. So we're going to have plus and minus 90 plus k times 360 when k is an element of integers. Another one, second function cos of, oh, I apologize, guys. I said 0 instead of 1. Yeah, supposed to be 1. So obviously if it's 1, second function cos 1, that would be 0. So it means this value here, it's 0. Remember, we don't have plus minus 0. So it means the value here, it will be 0. plus k times 360. Then now we're going to get the general solution for cos with -1. Second function, cos of -1. This will give us, it means the value of x for this expression here. This one. That will be x equals to plus or minus 180. Plus k times what is the period for cos 360. And the last one will be tan x, because remember I was solving for these two. So what is the general solution for tan? Tan must have one solution, general solution. So this will be 0 plus k times 180. The k is an element of integers. So that is the answer. So for undefined all the time, the denominator must be equals to 0. I believe you are following. Okay. So just go through the question. You can pause and do your workings. Wherever you don't understand, then you can reach out to me. Right. Then now the next one, which is 1.4. Okay. Okay, let me do this. Share again. Okay. With the 1.4, this is out of 8 marks. It says simplify the following to a single trigonometric ratios. So we need to simplify this ratio. All right, let's go through the question. First, we are given 90 minus x minus 270, 360 minus. So this is actual reduction formula. So we need to reduce them. But before reducing them, first of all, look at this. This one is a negative angle, this one. And how do we actually change angles from being negative to positive? If we have x minus 270 degrees, this one is a negative angle. When we have a negative angle and we want to change it to being positive, we can add there by 360 all the time. So it means this will become x plus 90. So minus 270 plus 360, that will give us 90. So it means if we rearrange this is the same as 90 plus x. So it means I will say, okay, fine, let me write this again. So this will become, okay, fine, it's okay. This will become sine 90 minus x divided by cos 90 minus x. Remember, sine over cos is the same as tan. Multiply by cos. I'm changing this expression here. It's the same as 90 plus x. I hope you're following. Multiply by tan 360 plus. This is the reduction formula. Divide by, remember, we need to reduce these angles. First of all, we have 240. 240, we have to reduce this by using special angles. Obviously, in most of the cases, you can use 240 is closer to 270, but to avoid co-functions, let's use 180. Which angle can I add on 180 to get to 240? Obviously, that will be 60. So 180 plus 60. 180 plus 60, it's 240. Times tan 225. 225 is close to 270, but let's use 180 plus. So 225, you know why I'm using 180 plus? I'm avoiding co-functions. 180 plus 45. Times tan 315 is closer to 360, but it's below 360. So which angle can I subtract from 360 to get 315? Obviously, it's 45. So now I'm gonna, first we need to, since we have rearranged everything to be in a reduction formula, we need to identify in which quadrant does they fall. 90 minus an angle is in the first quadrant. 90 plus it is in the second quadrant. 360 plus is in the first quadrant, I mean to say. 180 plus it is in the third quadrant. 180 plus also it is in the third quadrant. Sorry, 360 minus it's also in the fourth quadrant. Remember here, when we are dealing with 225, we can, someone might use 270 minus, still fine. But to avoid co-functions, the best way is to use that. Right, 90 minus an angle, we said is in the first quadrant, where sine is positive, But because of 90, it will change and become cos. Remember, we change after when we've taken the decision whether it's positive or negative. Divide by. 90 minus also is in the first quadrant where cos is positive, but because of 90, it will change and become sine. Multiply by. 90 plus it's in the second quadrant where cos is negative. But because of 90 change, it becomes sine. Multiply by into 360 plus is in the first quadrant where tan is positive, then this becomes tan x. But remember, since this is a fraction, it's either I change this as 1 over tan, it's also fine, or I make this one to be over 1 because these are fractions. Then everything divide by 180 plus is in the third where cos is negative, but it's not going to change. This will be negative cos 60. Multiplied by tan 180 plus an angle is in the third quadrant where tan is positive. It's not going to change because it's not a co-function. 360 minus is in the fourth quadrant where tan is negative. So this will be negative tan 45. So working out this, if we do not change cos over sine into 1 over tan, we can say since there's multiplication here, this and this can divide here. So what are we going to remain with? We are going to remain with cos x with minus 1 and tan x. This will become negative cos x multiplied by tan x. Divide by. What is cos 60? This one has special angle. Cos 60 is the same as half. Tan 45 is the same as 1. And tan 45 is going to be 1, so it's going to be negative 1 that side. So they said we must write this into a single trigonometric ratios. So at the numerator, what do we have? We have negative cos x. We multiply by tan. What is tan? Tan is sine over cos. Then we divide by minus half multiplied by 1 multiplied by minus half. This becomes half. And at the numerator, since sine over cos is a fraction, we can make this one over 1. We know for multiplication, the terms can divide. So we're going to remain with minus sine x over half. And what is the final answer? The final answer is minus 2 sine x. And I need to check something. Let me check something first. Okay, now I'm following. So into a single trigonometric ratios, then that is the answer. I believe you understand how I changed this to this. Because this is sine minus sine x divided by half, which is the same as minus sine x over 1 multiplied by 2 over 1. So the answer would be that. I believe you are following, guys. I believe you are following. Then the next one, it says 1.5 Prove that sine 2x minus tan x equals to, divide by cos 2x equals to this. And for which values of x will the identity be undefined? Same as the one I said earlier. So I want you to try this on your own to prove whether the left and the right are equal. So they want us to prove that the left and the right hand side are equal. Okay. While we are proving, we can just say, let's move on to the next question. Then 1.5.2, then you will solve like the first one, you'll do it 1.5.1, you'll do it. Then the second one will do it together. So the question says, for which values of x is the identity undefined? What did I say? I said for undefined, we were given an expression. If it's a fraction, denominator should be 0. So what is our denominator here? Denominator is cos 2x. But it's not the only denominator because look, we have this tan. Tan is the same as sine over cos. So it means even cos x, it's also a denominator on the right-hand side. So you see that we can determine the general solutions for x because they did not tell us anything. They did not give us the boundary. So we know cos has how many answers? 2 answers. So this will be cos 2x. I'm saying 2x, second function cos 0. This will be plus minus 90 plus k times the period of 360. K is an element of integers. The second one, second function cos 0, this will be plus minus 90 plus k times 360 when k is an element of integers. But since you are solving for x, you cannot divide everything by 2. So this will be plus minus 45 plus k times 180 when k is an element of integers. So these are the general solution. I'm saying it's the values of x that will make this expression to be undefined. For example, if we say where there is x here at the denominator, you put 45. This will be cos 2 times 45. You should just actually 90. And what is cos 90? Cos 90 is 0. Any number divided by 0 becomes undefined. I believe you're following, guys. I believe you're following. So try to prove the 1.5.1 on your own. For undefined, when you are given a fraction, the denominator should be 0. You solve the general solutions of expression if you are not given an interval. Okay? The next one, out of 8, this is also applicable for grade 11s. It says determine the value of the following without using a calculator. Right, the first one, it says sine minus 120. If they say without using a calculator, in most of the case when we have angles like this, means it requires you to use special angles. And special angles goes with reduction formula. So first of all, we have negative 120. Negative 120, negative angle is in the fourth quadrant. Or another way would be, remember I said when we are given a negative angle, you can change that negative angle by adding 360 on that negative angle. It means this is the same as sine 240. So it's sine 240. It cos 660. It's tan 315 without using a calculator is in brackets, cos 10, I'm saying cos 310 multiplied by sine 140 plus sine squared 410. So what we're going to do, we are going to reduce this using our special angles and the reduction formula. 90 minus 90 plus 180 minus 180 plus 270 minus 270 plus 360 minus 360 plus. All students takes chocolate. Okay, fine. Let's reduce this. Remember, I'm trying to avoid co-functions, so it means I have to play around 180 and 360. Okay, 240 is closer to 180, but it's above 180. So it will be 180 plus 60. 180 plus 60 is 240. Okay, then the second one, 660. 660 it's a bigger angle. So if we want to reduce the 660, what are we going to do? We are going to draw our reduction formula. Try to increase the angle 0, 90, 180, 270, 360, 360, 450 if we increase by 90, 540, 630, 720. You see that 660 is closer to 630 or 720. So you can use 720 or 630. But if you're using 630, this becomes a co-function. It means your ratio must change. If you're using 630, your ratio must change. But if you're using 720, your ratio will not change. Co-functions. So we can choose to use 720 or 630. If you're using 630, remember your ratio must change. So you can use both. But on my side, since I don't want to change my ratio, I will use 720. 720, this is 720 above. This is 720 below. So it means this will be cos of 720 minus 60. 720 minus 60, it's 660. So it's one the same thing. Even if you say 660 plus 30, it will still be in the fourth quadrant. Times tan 315 is the same as 360 minus 45. 360 minus 45, it's 350. Divide by, without using a calculator, guys, into, let me put inside the brackets. Let's reduce cos 310. Cos 310 is an angle closer to 360. So 360 minus 50, that will give us 310. You see, 50 is not a special angle. What does it mean? It means that we must continue using it. It means along the way we must get 50. So this will be 360 minus 50. 360 minus 50 is 310, it's fine, into sine. So it means we need to also try to reduce 140 to have 50. And how are we going to do that? Because remember, 180 minus 140, it's 40. So 40, it means now what are we going to do? Because it's okay, fine. So we can do this in two ways. One can change the first one by using 40. It's also fine. But now, since I've used 50, means I have to also change this one to a 50. And how am I going to do that? Obvious, 90 plus 50, this will give us 140. So now I have to use co-function, 90 plus 50. Why am I using 50? Is because I got 50. So it means someone might say 270 plus 40 for this one. But if you're saying 270 plus 40, it means this side you must say 180 minus 40, so that you must have 40 both. There are many ways to skin a cat. There's no problem with that. Okay, inside the bracket, I hope you're following. Because you remember some of the ratios, if you don't get special angle, it shows you that you need to reduce those angles. At the end, they will be simplified. Okay, then we're gonna do this. Remember, if we have sine squared, this is the same as just saying having It means this will always be positive. So you're going to have sine, then I'm going to put this squared, the 2, the squared, this is for this one. So I'm going to say sine, remember I have to reduce this to have 50. Why 50? Because I've already used 50 this other side. 410, how can I have 410? I mean to say, how can I have 50 when I have 410? Okay, let me check something. Yes, it's 410. 410 is the same as 360 plus 50 because I want to have 50 inside. 360, why am I doing this? Because I've reduced my angle to a 50 there. So now let's simplify this. 180 plus is in the third quadrant, where sine is positive, is negative. In the third quadrant, sine is negative because the one that is positive is tan. So you're going to have negative, because it's not a co-function, negative sine 60 multiplied by 720 minus, I think I've indicated 720 minus, it's in the fourth quadrant. And where cos is what? It's positive, but it's 720 is not a co-function. So this will become cos 60. Multiplied by 360 minus an angle, fourth quadrant also. Where tan is negative, so this will become negative tan 45. Divided by 360 minus an angle is in the fourth quadrant where cos is positive, and it's not going to change its co-function. So this will be cos 50. 90 plus an angle is in the second quadrant where sine is positive, but because of 90, it has to change and become cos. So it's going to be cos 50 plus into 360 plus an angle is in the first quadrant where all the ratios are positive, but because of, it's not going to change. This will become sine 50, but in all squared. Now let's work out this. What is sine 60? Sine 60, it's root 3 over 2. So since there's a minus there, we're going to say negative root 3 over 2. What is cos 60? Cos 60 is half. And what is tan 45? Tan 45, it's 1, so it's going to be negative 1 over cos A multiplied by cos A. These are multiplied. This becomes cos squared A. I'm saying cos squared 50 plus sine squared. This is the same as sine squared 50. So you see that sine squared, cos squared 50 plus sine squared 50 is an identity, is equals to 1. So which means we can just multiply the numerator because the denominator is 1. So we're going to have negative root 3 multiplied by half, multiplied by negatives. This will be root 3 over 4. Then we divide this by 1. So the final answer is root 3 over 4. So root 3 over 4 is the same as, I'm saying, we have evaluated that to root 3 over 4. That is the answer. I believe you guys are following. You can also reduce up to using 40. It's also fine. There's no problem. Like, for example, here, someone might say, if you don't want to use on 240, if you don't want to use 180 plus, you can say 270 minus 3. The answer will still be the same. But however, if you're using 270, your function must change from sine to cos. I believe, guys, you're following. Okay. Just a minute, guys. I want to raise these questions. 1.6, yes, 1.7. And this is one of the most important questions, guys. If sine 32 equals to t, if sine 32 equals to t, determine in terms of t, very important, the following. You see, in most of the cases, if they give you an expression like this, and they say in terms of something, you need to always have a right angle triangle. Not inside the Cartesian plane. You can construct also in the Cartesian, but there's no need. So now, if they say in terms of something, in terms of k, in terms of t, expression like this require you to have a right angle triangle. So what are we going to do? We're going to say, okay, fine. We know that sine 32 equals to t. But sine is a ratio, which means this one must be divided by 1. Sine its opposite over hypotenuse, which is the same as y over r. So it means we already know the value of y. Y is t, and the value of r is 1. And we also know the angle. So I'm going to put the angle here as 32. And we know that angles that are inside the triangle must add up to 180. So what will be the other angle here? The other angle will be 58. So within this will be our temporary special angle if we want to answer this question. So it means we have 32, 32, this will be the opposite. The opposite here, we know the opposite is the t. The hypotenuse we know is the 1. So it means we have to get x. And to get x, it means you have to use theorem of Pythagoras because this is the right angle triangle. So we're going to say x squared plus y squared is equal to r squared. We do not know the x, not the y is the t, the r is 1. So this becomes x squared equals to 1 minus t squared. Then we apply the root sign, but here we do not have to apply plus and minus. So the x will be the root of 1 minus t squared. And guys, you have to leave your expression like this. Because some learners find that they say root 1 and root t squared is then the same as 1 minus t squared. It's wrong. Minus t, it's wrong. Can't do that. Okay, now we know that in our right angle triangle, we have all the information. So now you understand how we got this. Let me just try to raise here. So it means now we know the adjacent there. The adjacent is the root. It is the root of 1 minus t squared. So we must write this. So we expanded sine 32 as a fraction, then we had our right angle triangle. I believe now you are following. So let me get rid of this now. So which means in our equation, since this applies to grade 11 and 12. So this is our temporary special angle. So it means if you want to solve this, you must use this temporary special angle. Now the first one says determine the value of t, in terms of t, the value of the following. The first one is sine 212. So 212, we do not have 212. It means you have to reduce this angle 212 to have either 32 or 58 using the reduction formula. So we can work it like this. 212 is an angle bigger than 1. Remember, I said let's play around 180 and 360 on our reduction formula. Unless if it's a must for us to use cofunction, there's no problem. 212 when 212 is the same as 180 because 212 is bigger than 180, so it's 180 plus 32. Remember, whatever you write it should be the same as this. So 180 plus 32 is the same as 212. Remember, someone might use 270, it's still fine. But if you're using 270, it means this will be sine 270 minus 58. The answers will still be the same. But with 270 means you have to change your cofunction. 180 plus an angle, which quadrant? 180 plus is in the third quadrant, where sine is negative. But it's not going to change because we're not using cofunction. So this will be negative sine 32. But already we know sine 32, we're given sine 32 is t. So it means the final answer is negative t because they said in terms of t. Same applies with this. Even if we use this 270 minus an angle, it is in the third quadrant, yes? Where sine is negative, but because of 270, it will change and become cos 58. Now we're using cos. Cos is adjacent over hypotenuse, but of 58, what is the adjacent? This is the opposite then. Adjacent will be t, hypotenuse will be 1, so it will be t over 1, which will just be negative t. So the answers are the same. I hope you are following. 122. 122, it's an angle closer to 180. So let's check. 180 minus 122, it's 58. So it's closer to 58. So we have 58 there. So this is the same as cos into 180 minus 58, because it's below that. It's below 180. So 180 minus 58 will give us 122. And 180 minus an angle is a reduction formula. In which quadrant 180 minus? It is in the second quadrant, where cos is negative. But yeah, it's not going to change. This becomes cos 58. And what is cos 58? We already got it. Cos 58 is, it's adjacent over hypotenuse t, but you're going to have minus t there. Another way would be, you can use 90 plus. Another way you can say cos 122 is the same as cos 90 plus 32. 90 plus 32 is also the same as 122. But don't forget, once you use 90, cofunction must change. 90 plus an angle, which quadrant? It is in the second quadrant where cos is negative. So it will be negative, but because of 90, it becomes sine. Sine 32. Already we know sine 32, it's t. So it means the answer is negative 2. Same. Same answer. Okay, then now 1.7.3 says cos 64. Cos 64. Do you have 64 there? No, we do not have 64. But 64 is the same as 32 plus 32. 32 plus 32 is the same as 64. So which means we can write that as a double angle to say the cos 2 times 32. 2 times 32. Let me just work it like this. Yeah, 2 times 32 is the same as 64. But if you look, I've written this as a double angle for cos. And we know double angle for cos the same as cos 2a is the same as cos squared a minus sine squared a, or 1 minus 2 sine squared a, or 2 cos squared a minus 1. We can choose any of these. It will give us the correct answer. So since now we have sine 32, it's t, we can just use this and say, okay, we know that cos 2a is the same as 1 minus 2 sine squared a. So what we're going to do, we're going to say where there is a, we substitute by 32. Wherever we see a, we substitute by 32. Because 2 times 32 is 64. So it means cos 64 equals to 1 minus 2 into. Remember, what is sine 32, guys? Sine 32 is t. But since here, when I have sine 32 in all squared, because this is sine 32 squared, so it means the final answer is 1 minus 2t squared. It's not the only approach. You can also use any of these. The answers will be the same. The answers will be the same. For example, if we use a double angle for cos, for the one that has cos only, we will still get the same answer. If I say cos 2a, it's 2 cos squared a minus 1. Where there is a, we substitute by 32. And what is cos 32? Cos 32, remember this is the opposite adjacent. So the adjacent over hypotenuse, this will be the root of 1 minus t squared divided by 1, which is just squared because there's a squared here, then minus 1. We know that once you square both sides inside the root equation expression, then the root sign will be out. So we're going to remain with 2 into 1 minus t squared minus 1. Let's expand this by multiplying by 2. So it's 2 minus 2t squared minus 1. You see, what is 2 minus 1? This gives us 1 minus 2t squared. Still the same answer. Still the same answer. Another way would be, if we do not want to write this as a double angle, we can also write it as a compound angle, because 62 is the same as 32 plus 32. So one can do it like this, can say, okay, fine. Cos 64, since I have 32 there, is the same as cos 32 plus 32. You see, I'm writing it as a compound angle for cos. And we know compound angle for cos says cos, cos, sine, sine. So this become cos 32 cos 32 minus sine 32 sine 32. You see, cos 32 alone is the same as root cos 32 adjacent over hypotenuse. It's root 1 minus t squared. Same applies, cos 32 alone, it is the root of 1 minus t squared. Minus sine 32 alone, we know is t. And if this one becomes t. So if we simplify this, the root of 1 minus t squared multiplied by the root of 1 minus, this gives us 1 minus t squared. Minus t times t, this becomes t squared. If we group like terms, this will be 1 minus t squared minus t, this becomes minus 2t squared. There are many ways to skin a cat. The answer is the same. The answer is the same. You still get the same answer. There's no problem. Practice makes perfect. Right, let's move on to the next question. Because of time, guys, I'm not gonna be, I will not finish the paper, but you need to make sure that you go through this, you practice on your own. Then the other one is 1.7.4. It says sine 16, sine of 16. Let's check the 16 there would not have 16. But if you take 32 divided by 2, it gives us 16. So this is a half angle actually. And since it's a half angle, it means we use that 32 as a double angle in order to get the half. But now we want sine 16. Look at this. Since we want sine 16, we're going to use the double angle for cos like this. We're going to say that 16 times 2 is the same as 32. So it means we're going to say, okay, cos 2a, it's 1 minus 2 sine squared a, according to the double angle. So which means that we're going to say, okay, fine. If where there is a, we put 16. Wherever there is a, we substitute by 16. 2 multiplied by 16 is 32. We have that. And this is the same as 2 sine squared 16. We want this sine 16 here. So we know this will get cos 32 here. What is cos 32? Cos 32 is the root of 1 minus t squared. Then we're going to say 1 minus 2 sine squared 36. Oh, 16, I mean to say. So now we want to make sine 16 the subject of the formula because it's what we want. So to do that means we can do this. We can transpose root 1 minus t squared to the right hand side. Then we transpose 2 sine squared to the left. So this becomes 2 sine squared. This 16 equals to 1 minus the root of 1 minus t squared. And we divide here by 2 both sides. And this will give us sine squared 16 is equals to 1 minus the root of 1 minus t squared divided by 2. And since we want sine 16, it means now we're going to just put the root sign without allowing plus or minus. So it means sine of 16 here, it is the root of 1 minus the root of 1 minus t squared over 2. So this is the answer. And this question was, there was a question of this format in the trial examination paper for Limpopo, especially this one. But it was talking about 12. You were given 24, then you have to use 12. Practice makes perfect, guys. This is a half angle. Okay, now I believe you're following. Then the last one, 1.7.5, it says cos 77. Remember, we need to use the special angles, temporary special angle, the one we have there, 77. Let's check. Do we have 77 there? No. Let's try to reduce 77 to have, maybe try to have that obvious 90 minus 77, it's 13, and 13 is not there. So what are we gonna do? Okay, we're gonna say, okay, fine. You must think, guys. These are the temporary special angles. 58 and 32 are the temporary special angles, but we know special angles. Where we know 30 is a special angle. We know 45 is a special angle. We know 60. Can't we incorporate this together with this and try to check if we can't get something? Obvious. If we take 40, 45, we add with, we combine with 32, what do we get? Oh, this is 77. It means now we use the special angle, the actual special angle and the temporary special angle. So it means now we're going to say, okay, fine. Cos 77 is the same as cos 45 plus 32. So I've written this as a compound angle for cos. And we know the compound angle for cos, it's cos, sin. So this becomes cos 45, cos 32, minus sin 45, sin 32. Cos 45, we know it's root 2 over 2. Cos 32, we'll get it from our temporary, temporary special angles. Cos 32 will be the root of 1 minus t squared. Sin 45 will be root 2 over 2. Sin 30 is t. So if we can either multiply or remove the brackets, I'm going to say take a common factor. The common factor will be root 2 over 2. Then you're going to remain with root of 1 minus t squared minus t as the answer. That is the answer. I believe, guys, you're following. I believe you're following. That is the answer. Practice makes perfect. Practice makes perfect. Okay? Remember, question changes, but the more you practice as many questions as possible, it will be easier for you to answer questions in the examination room. Because once you look at the question, you know, okay, I have seen this type of a question. I remember I can be able to get the correct answer. So you need to practice as many questions as possible. Okay? So now, this one, question 10 is for the general solution. I think this one I can leave it for now. Then you must first go and check and look at the general solution questions that side. Then you come back to question 10 on your own. Wherever you are struggling, then you'll make a comment in this video, in the YouTube channel. Then I will get back to you. Okay, then now, 1.8. 1.8 says, prove that cos 3a equals to cos 4 cos cubic a minus 3 cos a. So we want to prove that cos 3a is the same as the left and the right are equal. And how are we going to do that? I want you to do this. We're going to say, okay, fine. Cos 3a is a triple angle. Cos 3a, it is a triple angle. And since a triple angle, we cannot just write as a plus a plus a. It means now, what do you know? We are used to double angles. We are used to double angles, not compound angles, and not triple angles. We are used to the double angle of sine, which is cos squared a minus sine squared a, 1 minus 2 sine squared a. They're there in the formula sheet. 2 cos squared a minus 1. And also the double angle for sine, which is equals to 1. Expression is 2 sine a cos a. Okay? Then it means we have to make sure that since there's triple angle here, we need to include double angle in it. So this will become 2a plus a because we are used to double angle. So I've changed this triple angle to now become a compound angle. And this is a compound angle for cos. And we know in terms of cos, it's cos, sine, sine. So this become cos 2a, cos a, minus sine 2a, sine a. But let's look at what we want to prove. We want to prove this. We want to change this to become this. And if you check here, we only have cos only, which means anything that is not of cos, we need to change it. I believe you're following. Okay? Then look here, guys. This, it's a double angle for cos, is this one. This is a double angle for sine. Obvious for sine, then it means we're going to substitute this. But if it's for this one, we need to be careful. Don't just take any. You need to try to work smart. Since we want to remain with cos only, it means you must go and take the double angle for cos only there. So it means this will be 1 minus, oh, not 1 minus, I apologize. So we want to use the one that is cos only. This will be 2 cos squared a minus 1. Outside there's cos a. Minus, this is the same as 2 sine a cos a multiplied by sine a. Let us remove the brackets here. Cos a multiplied by 2 cos squared a. This is 2 cos cubic a minus cos a multiplied by 1. This becomes cos a. Same applies. 2 sine a cos a multiplied by sine a. This becomes 2 sine squared a multiplied by cos a. But now, guys, look at this. We want to remain with cos only. And there is a problem here, sine. And we can change that because we know that sine squared a plus cos squared a is 1. Which means if we make sine squared a the subject of the formula, it will be the same as 1 minus that. So it means we can rewrite this as 2 cos cubic a minus cos a minus 2 into, where there is sine squared a, we can put 1 minus cos squared a, but still there is cos a here. Now let us remove the brackets. This is 2 cos cubic a minus cos a. 2 multiplied by cos a, this becomes 2 cos a into 1 minus cos squared a. Then we remove the brackets again. 2 cos squared a minus cos a. 2 cos a multiplied by 1, this becomes 2 cos a. Negative 2 cos a multiplied by negative cos squared a, this becomes positive 2 cos cubic a. Then we group the like terms. This and this one are like terms. Sorry, this is a cubic. 2 cos cubic a plus 2 cos cubic, this becomes 4 cos cubic a, like terms. Cos a minus cos 2 cos a, this becomes minus 3 cos a. So now we have proved our identity. Then the second question says, hence, which means using whatever you just proved now. Without using a calculator, determine the numerical value of this. We want the value of this guy. So to answer that, we're going to say, okay, fine. What did I say? Look at the condition given there. They gave us a condition, and this is very important with that condition. They told us that we need to determine cos 3a if tan A equals to 3 over 4. If tan A is equals to 3 over 4, we need to be careful here. Since tan A equals to 3 over 4, we're going to say, okay, tan of an angle is 3 over 4. And what is tan in terms of SOHCAHTOA? Opposite over adjacent, which is the same as y over x. So we know the value of y. By the way, let's look at this value. Is this value a positive or a negative? It's a positive. So it's telling us where tan is positive because we are given a condition there. So tan is positive in the first quadrant and in the third quadrant. 0, 90, 180, 270, and 360. But there's a condition that says this angle of A should be bigger than 90 or 180. So it means we must look from 180 and above. Or it means our right angle triangle should be in the third quadrant because that's where the angle is bigger than 180. So that is it's very important to consider the guidelines, guys. These guidelines are very important. Conditions are very important. So it means I want to construct our right angle triangle in the fourth quadrant. Remember, the angle should be measured from the positive x-axis. So this is our beta here. We know our beta. This is for beta, not 3 beta. And since this is our beta, the y value there, because now we're in the fourth quadrant, you must be careful here. The y value in the fourth quadrant is negative, and the x value is also negative, which means these values that we're going to get, we must apply both. They must be both negative because negative 3 over negative 4 will be negative, will be positive. So it means the actual value of y here, the value of y is minus 3, and the value of x is minus 4. I hope you understand why I'm saying that. So we have minus 3 there, and we have minus 4 there. Because minus 3 is the opposite over, I just said minus 3 divided by minus 4, it will still give us 3 over 4. Because in the third quadrant, x is negative and y is also negative. So we must get the r. R is always positive. So the x is minus 4, we're going to square this. The y is minus 3 squared. So it means this will give us 16 plus 9. Then this gives us 25. The root, we apply root sign, and the r becomes 5. Remember, it's always positive. So in that case, we can be able, remember they say without using a calculator. So we can be able to get that cos 3a, because we know cos 3a, it's 4 cos squared. Remember, this uses the angle A, not the B, so the A. So cos squared A, we can get it there, and cos A, we can get there. By the way, what is cos A? Cos A, it's adjacent over hypotenuse. What is the adjacent there? Minus 4. Hypotenuse is 5. So it means wherever we see cos A, we're going to put minus 4 over 5. Minus 4 over 5, but this one is a cubic. Minus 3 into minus 4 over 5. So then we're going to get the final answer. So now let's work it out. 4 into minus 4 over 5 cubic. Then minus 3 into minus 4 over 5, not squared. And this gives us 44 out of 125. 44 out of 125 is the answer. I believe you guys are following. I believe you're following. 44 over 125. Okay. Remember, practice makes perfect. If you don't understand the thing, please don't be shy to comment in the YouTube channel under the video, then I'll be able to respond to you as soon as possible. Don't forget to like, share, and subscribe. And to hit the bell button for future video notifications. That would be much appreciated. Okay, the next one point, I think this will be the last one because I said the other one is the general solutions. Wherever you like, you must first go and watch the first video for the general solutions, and after that you're gonna write this. It's just that due to time, then I'm not gonna be able to go through it. So then 1.9 it says, consider cos x. Consider cos x. Consider cos x plus 2 cos x plus 240. Then the question says, simplify the expression above to a single trigonometric ratios. So it means you're going to do this. You're going to say, okay, cos x plus 2. Remember, this is a compound angle because it's 2 angles being added. Is the compound angle for cos. It means it become cos, sin, sin. So it's cos x cos 240 minus sin x sin 240. So if we simplify this will give us cos x plus 2 into, remember they said if we, without using a calculator, we have to reduce 240. 240 is the same as 180 plus 60 minus sin x sin 180 plus 60. 180 plus 60, it is 240. So now what are you going to do? You're going to say, okay, in which quadrant do we have 180 plus an angle? 180 plus an angle is in the third quadrant. It is in the third quadrant. Where sin, the first one, so this will give us cos x, I apologize, plus 2 into cos x. 180 plus is in the third quadrant where cos is negative. So this will become negative cos 60 minus sin x times 180 plus is also in the third quadrant where sin is negative. So this will be negative sin 60. It's not a cofunction. So if we simplify this will become cos x plus 2 into, what is cos 60? Cos 60, it's half. It means if we substitute this will be cos x multiplied by minus half minus sin x multiplied by sin 60. Sin 60, it's root 3 over 2. Right, if we multiply this will become cos x. Let's remove brackets by multiply by half throughout. So this will become minus, okay, let me just do this to avoid confusion. So you're going to have minus half cos x. Then you're going to have plus root 3 over 2 sin x. I hope you're following. Then let's multiply by 2 throughout. By 2, this will become minus cos x. That will become root 3 sin x. Let's group the like terms. Cos x minus cos x is 0. So we're going to remain with root 3 sin x. Then the last one says, hence determine the minimum value of the expression. By the way, this has to do with the issue of graphs. When you have y equals to, let's say, a sine bx, this a here is called the amplitude value. It is the amplitude. And that amplitude is the one that determines the range of the graph in terms of a minimum value or a maximum value from minus A to a positive A. This is a minimum value and this is a maximum value. For example, if we say we have y equals to 2 sine x, the amplitude here is 2, which means the minimum value of the graph will be minus 2 and the maximum value will be 2, which will affect the range. So now, in that essence, what is the minimum value here? Remember, the amplitude here is √3. Now we want the minimum, not the maximum, because the maximum has to be √3. This is actually the maximum. So it means the minimum value will be minus √3. So the answer for this is negative √3. Is the minimum value. It's negative √3. I believe you're following. I believe you're following. Yes. So you can go through the questions on your own. Okay, I apologize, let me not erase this. So you can go through the questions on your own, and where you don't understand, kindly reach out to me. Then that will be much appreciated. So now, in terms of this, so the answer already we know that the minimum value is negative √3. So you need to make sure that you go through the paper on your own. Remember, practice makes perfect. Thank you very much. See you in the next session for part 2. Bye.